Today I'm going to do a comparison between the 130mm Newtonian reflector and the 80mm short tube refractor. Neither of these are in existence anymore. The closest I could find to the Orion Space Probe 130 was the AM Scope 130. You can tell it because it's red. Comes on an equatorial mount. And the Carson Red Planet 80. It's also red and comes on an alt-azimuth mount with slow motion controls. The AM scope sells for $270 with the equatorial mount. The Carson sells for $219 with the slow motion controls and the alt-azimuth mount. So they're of similar price, especially when you add in a $35 color SV Bony 231 color correction filter to the refractor. That brings that up to 20, 30, 40, 50, 55, and a $10 extension to add to the tube, so you don't have to use the 90-degree angle diagonal to take photographs. That puts them about $5 apart, and that's in spite of the fact that the reflector has a much more expensive mount. I haven't been able to get out lately, so I can't go out and take pictures of these. Fortunately, I have some pictures that I've taken recently with both of these in this configuration. For the Orion, I used my CG4 mount, and for the Celestron Nexstar 80, that's what this actually is, I used my Skywatcher AZ-GTI mount. This is a much better mount for taking an hour, 2 hours worth of subs. But if you're only taking 10 minutes worth of subs, there's no particular advantage of an equatorial mount over an alt-azimuth mount. They're both go-to mounts. And I've chosen photographs where I only took 10 minutes worth of subs for each of them. So we have the same photographs taken with similar conditions, although I don't have any photographs taken with the 80mm that does not have the SV Bony 231 color correction filter. So I can't show you big bloated stars with lots of chromatic aberration. In any event, it took me all day of research to find the two that would be closest to these. The Astromaster 80 is the closest that Celestron makes to this older Celestron model. And it comes with a handlebar mount and no slow motion controls, which is why I prefer the Carson. I do have a Carson tabletop Dobsonian I did a review on. They make good products. And I don't have any AM scope products, but studying the stats, I mean, it's got a parabolic mirror like this, a metal focuser. It's a good scope. The Skywatcher makes a 130, sells for 395 pounds in Europe. Doesn't sell any at all in the United States. It's better than this. It has a 2-speed focuser, and it's an astrograph kind of a, but that's out of the price range. That's extra nice. And Takahashi makes a really nice 80mm scope too, but that's, I guess I could sell the house and buy one. in any event, let's get to it. The trials and tribulations of trying to take photographs of the sky with anything other than a dedicated astrograph are numerous. For instance, inexpensive reflectors, Newtonian reflectors of less than 150 millimeter, are designed specifically for visual use, not photographic use. Because of that, you can't bring most of them to prime focus. The focal point is about a ½ inch too deep into the focusing tube. You can either take the telescope apart and move the mirror a ½ inch closer to the front, or cut the top of the focuser off about a ½ inch from the top. That might work unless you have a compression ring. Or, here's my camera, stick it in there, won't focus. An alternative is to use a Barlow lens. A Barlow lens, like this thing, doubles the focal length. Now we come to prime focus. But you get 1/2 the field of view and twice the magnification. If you buy a long ×2 Barlow, like this one, you can actually take it apart. This is just a hollow tube. This is the Barlow lens. What you can then do is screw the Barlow lens into the bottom of the camera, like this, and stick it in the focusing tube. And now you have a 1½ times Barlow. Instead of doubling the focal length, it increases it by 50%. And instead of having the field of view, it only reduces it by 25%. This particular telescope came with 2 spacers at the top. So if you couldn't come to prime focus, you could just take off one of the spacers, and then you would come to prime focus. Now the refractor, on the other hand, is typical. A lot of refractors won't come to prime focus unless you stick the diagonal in. I don't like having a camera up here at top facing down, so I got a little extension tube and added it to the end of the focusing tube, like this. That gave enough play, enough outward focus for this thing to come to focus. Took some experimentation, and it usually does when you're trying to come to prime focus for a telescopic camera. And it's even more difficult when you're using a 1¼ inch focuser instead of a 2 inch. But I was able to achieve both of those things. And now let's look at the photographs. First off, we'll look at M27, Dumbbell Nebula. Photograph on the left was taken with the 130mm Newtonian, the one on the right by the 80mm short tube. The Newtonian has a focal length of 650 millimeters. The short tube 80 has a focal length of 400 meters. Therefore, the short tube 80 has a larger field of view, and that's why the Dumbbell Nebula looks smaller than it does with the Newtonian. Both pictures came out fairly nicely. The 80mm refractor doesn't have a bunch of bloated stars with chromatic aberration due to the color correction filter. The Newtonian does have the diffraction spikes on the brighter stars. Refractors don't have diffraction spikes. They both came out nicely. Next, we'll look at M17. M17 is a nebula. Over here on the left, we see that the nebula is larger than it is on the right because the focal length of the Newtonian is longer than that of the refractor. The colors are different here. The color correction filter in the refractor isn't letting in as much blue light, so it comes out redder than it does in the Newtonian. But both of them are nice looking. And finally, we have M15. M15 is a globular cluster. You can see the greater detail in the reflector because it's zoomed in closer. Over here with the refractor, still looks nice. It's just farther away due to the increased field of view, and so you can't see the individual stars as well. And you'll find that that's the difference most of the time, no, all the time, between shorter and longer focal length. So that's the photographs. As you can see, you can get good results from refractors or reflectors. The reflectors are going to pick up more stars because they gather more light because they have a higher aperture per dollar. Reason for that is simple. To make a reflector, you take a slab of glass, you carve one side of it. You're done. Miller time. For a refractor, you have to carve two sides, both sides of an objective lens, and then two sides, both sides of a second lens to help with chromatic aberration. So you're grinding four sides instead of one. Plus, if you want to get rid of even more achromatic aberration, use something like FPL 51 or FPL 53, or add a third or fourth lens, all trying to clean up the color. You don't have to do any of that with a reflector. Reflectors are cheaper to make, so you get more aperture per dollar. Of course, reflectors also require a lot more maintenance. You have to keep the mirrors aligned. Every time you beat a moose to death with your telescope, if it's a reflector, you're going to have to realign the mirrors. Not so with a refractor. Plus, you have to take the mirror out of the back of the telescope on a regular basis to clean the mirror, because refractors are closed tube. There's an objective lens at one end and an eyepiece or a camera at the other end. With a reflector, you have a mirror at one end and a big giant hole at the other end. And Bernoulli's principle will suck dust, pollen, anything else that happens to come by at 2 mile-an-hour wind speed into the tube down onto the mirror. In fact, not only the primary mirror, but also the secondary mirror, the little flat mirror. That cost much to make, cheap. Take some glass, spray aluminum on it. And that's a decision that the end user has to make. Do I go refractor, a lot more expensive per millimeter of aperture, and a lot less maintenance, or do I go reflector? lot more maintenance, plus since you've gotten a lot bigger aperture, you'll have a much bigger, wider telescope, which means the wind will blow it more. So you'll need a stronger, more stable mount because you got a sail catching the wind. And that's the difference between the two telescopes. And as you've seen here, you can get pretty good photographs from either one. I used a SP Boney 705 camera for both of them, which has a IMX 585 chip, and they both came out pretty good. Before I go, some of you have subscribed. I really appreciate that. You're nice people. For those who haven't subscribed yet, if you like this kind of content, please do subscribe. It would mean a whole lot to me. It would be ever so nice. And if you don't like this kind of content, subscribe anyway and say mean things to me in the comments. Yeah. So until we meet again, happy trails.